Solutions Math 251. Asked to find a couple derivatives. We'll need logarithmic differentiation for both of these. So on the first one, I get y equals something, natural log of x in this case, raised up to some other power, the natural log of x. And I don't have any derivative rules that work when you have a variable in the base and up in the exponent. You might think a chain rule or a power rule or something. None of those work. Your only chance is to get this exponent, this thing out of the exponent. And you might think you can do that with the log rule, but you can't. If you're the natural log of x raised up to this power, like it is down here, by the way, you could. But here you can't. Here you have to take the natural log of both sides to get that this is the natural log of x raised up to the natural log of x power. And now you can apply one of your log rules to take this natural log of x and bring it down in front. And so you got this natural log of x in front, and then the natural log of this natural log of x here. And now you can take the derivative of both sides of the equation. The derivative of natural log of y is 1 over y times y prime. The derivative of a product here, I'll have to use the product rule. F prime is 1 over x. G is the natural log of the natural log of x. Plus g prime would be a chain rule. 1 over the natural log of x times the derivative of natural log of x, which is 1 over x, times f, which is just the natural log of x. You can clean that up a little bit if you want. You got y prime over y is equal to the natural log of the natural log of x divided by x, plus this natural log of x and this natural log of x cancel each other out. I got 1 over x. So y prime is equal to y times this stuff. I guess if I have a common denominator, I might as well add up the numerators to get to here. But I don't want to leave a y in my answer because y is something I invented. It's this thing right here. So I would get that y prime is equal to, instead of y, I could write the natural log of x raised up to the natural log of x power times the natural log of the natural log of x plus 1 divided by x. And yes, I know that's a mess. I feel like these are kind of fun, and I think I enjoy these more than maybe I should. Sorry about problems like this. The second one turns out is not nearly as bad. We'll still want to set it up using implicit differentiation, so the natural log of x raised up to the natural log of x power. But now I don't have to take the natural log. In fact, I guess I don't even have to set it up as implicit differentiation. I can just take the derivative, because I can say that this is the same as the derivative of, and then using a log rule, I can take this natural log of x down in front. So I get the natural log of x times, and then my base here would be the natural log of x. So I brought this natural log of x in front of this natural log of x I get here. But wait a minute, isn't that just the derivative of the natural log of x squared? Sure is. Something times something just means that thing's squared. You can take that derivative using the chain rule. The outside function is stuff being squared. So you get 2 times the natural log of x raised up to the 1 power times the derivative of natural log of x, which is 1 over x. So for your final answer, you get 2 natural log of x divided by x. Quite a bit easier than A, which was a total mess, where we got our answer was this huge mess over here. Next problem, related rates. So totally different from what we're doing up here. Essentially, all you need is this. You're told that h equals 1/2 pi r squared squared. Turns out that h is the hypervolume of a hypersphere, this 4-dimensional thing, which is kind of cool, but whatever. And r is the radius. But really, if you start out right here, and then it says the hypervolume, in other words, h is growing at a rate of this. So this tells you that h prime is equal to 1,000. And it asks you the question, at what rate is the radius increasing? This is saying r prime is equal to what? When the hypervolume is this thing right here. So this tells you, this was h prime, this was the rate that it was increasing. This tells you that h is equal to 8 pi squared. So taking all these numbers, I can plug them into what I'll get from this equation once I take the derivative of both sides. So I have this equation here. Oh, I wrote that wrong, sorry. this was just my equation. This came from right here. And this information here was h, which is equal to 8 pi squared. So this, I wasn't pulling information from out of the problem. I just was copying this equation right here. Anyways, this thing is what I'm going to take the derivative of both sides of. You can take the derivative right now if you feel like it, or you could say that this is equal to 1/2 pi squared times r to the 4th power. And then note that 1/2 pi squared is all just a constant. So I get h prime is equal to 1/2 pi squared times, and then the derivative of r to the 4th power is 4r cubed r prime. So h prime, which is 1,000, is equal to 1/2 pi squared times 4r cubed. Let's see, so I guess I don't know r, but I could figure out r from my original equation. I could say, maybe over here I'm going to find r. I know that h equals 1/2 pi r squared squared, and h is equal to 8 pi squared, so that's equal to 1/2 pi r squared squared. So if you multiply both sides by 2, you get 16 pi squared is equal to pi r squared squared. So if you take the square root of both sides, you got 4 pi is equal to pi r squared. And so if you divide both sides by pi, you get 4 is equal to r squared. So r is equal to plus or minus 2, but since we're talking about the radius, it would just be positive 2. So all this just to find r, which I can then plug in over here. This would be 2 cubed. And then r prime is what I was trying to figure out. So I got this equation to solve for r prime. If I multiply both sides by 2, I'd get a 2,000 up on the top. And then if I divide by pi squared times 4 times 8, that's what, 32 pi squared? I would solve for r prime. And this is a perfectly good answer. Maybe I'll say, or you could reduce this a little bit. Let's see, I think 8 goes into both of those. Yeah, actually 16 goes into both of those. That's 125. This is dangerous to do this without a calculator. Over 2 pi squared, I think. Because, let's see, 16 times 125 is the same as 8 times 250, and 8 times 250 is 2,000, and 16 times 2 is 32. Yeah, so either of these answers are totally fine for r prime. Whew, all right, tough quiz. That's the end of this one. I'll stop the video here.